Today, we will cover our second method in outlier detection using a statistical approach. For our new technique, we will be going back to a statistical approach like we previously used in quantiles. However, using our new technique takes it up a notch from quantiles to increase performance for detecting outliers. For this video, we will address the use case by another type of statistical approach called distributions. To train our model, we have this workflow that starts with reading in our sample dataset from Kaggle. Next, we do some minor pre-processing where we change the target column from 0 or 1 to more relevant meanings. We apply the z-score normalization on all the numeric columns to help standardize the features. At the top, if we go into the statistics node, we can see more information on our data and view the distributions. Now, after checking the distributions, we can then filter out a specific feature column using the column filter. After this, we want to remove the tails by excluding any values outside of our 95% confidence interval. From here, we feed all our data again to the top port of the reference row filter and our reference column data to the bottom. The node will filter our original data based on the input we passed to the bottom port. After our filter and isolate step, we need to pass this into our component that will help us mark the outliers for testing. If we go inside the mark outliers component, we have a reference row splitter that handles our logic for determining outliers. The way this node works is by passing in a reference table to the bottom port. It will use that to split the table passed into the top port. For our case, we want to pass the reference table we just made to the bottom and our sample data to the top. The bottom port will output the outliers where they can be marked with a rule engine node. If we are satisfied with the performance, we can go ahead and save the model by writing it to the disk so we can use it for our deployment workflow. Inside the score node at the end, we can see the correctly classified transactions and the mistakes. At the bottom, we can see we got an accuracy of around 96%, which is very good compared to our last statistical method we used. Now, if we pull up on the right side what we got from quantiles, we can see we have an accuracy of around 84%. By using distributions, we have increased the accuracy by about 12%, which is great as the overhead for statistical methods are a lot lower than some of our more advanced techniques we covered. To deploy our model, we can use this workflow here to classify a new transaction. On the left, we read in our saved model and the new transaction. Next, we follow the process for classification as in our training model and create a table to pass into our mark outliers component for classification. If the transaction is suspicious, we will go ahead and send an email, otherwise we won't. You can download these workflows on the Knime for Finance space under Audit and Compliance. Feel free to check out our other techniques used for fraud detection.